Another 7 Caillou series challenge coming at you. We have sum of two lowest positive integers. Create a function that returns the sum of the two lowest positive numbers given an array of minimum 4 positive integers. So the minimum size is 4, they mean. No floats or non-positive integers will be passed. For example, when an array is passed like this one, 19, 5, 42, 277, the output should be 7 because the two smallest elements are 5 and 2. When you add those together, you get 7. If that's not clear, go ahead and look at this other example with some ridiculous entries. And you'll note that this number and this number are the two lowest. And when you add them, you get this. So I think that's clear. Go ahead and crank this one out. Come on back when you're ready. So to solve this, we're going to verify input as a good practice, and then my strategy will be to sort of maintain a note about what the two lowest values found in the array are, and we'll go over each element in the array. We'll update between the two minimum variables, always keeping the lowest two, and then as we finish that loop and we've scanned all elements, we'll be able to simply add the two integer variables that we created that store the two lowest values, and we can return that. So first things first, they're saying it's going to be at least 4 positive integers. So let's just do some input validation there. If numbers.length is less than 4, throw new argument exception. We'll say input size needs to be greater than 3, right? It's got to be 4 or bigger. So provided we get past that line, that means we have at least 4 elements in our array. Good on that part, and we'll also enforce the idea that they're all positive too. You don't have to do this, it won't come up in the solution, but I just like to get people thinking that way. So we said we were going to have 2 integer variables. I'll call them min1 and min2. And to start, there's a couple ways you could do this. You could just take the first 2 numbers in the array, in this numbers array, and assign them to min1 and min2. And then when you loop, you could start at index 3. Well, index 2 with 0-based numbering, right? Index 0 would be this value, index 1 would be that value, and then we'd loop from I equals 2 to the size of numbers. But another way, I figured I'd show you something maybe you weren't familiar with. I'll just set these integers to the maximum value that can be stored in an integer, and then I'll scan over the entire array, and we'll just update those values as we encounter lower ones, because every value we encounter has to be lower or equal to the maximum integer size, right? You can't have something above the maximum possible integer size. And so the int32 class has this handy max value field. You can see it there, 2 billion. So we can use this to start out with the highest possible value. And then you can imagine as we hit the value 19, it's going to say 19 is less than 2.1 billion, right? So we'll go int32 max value. We'll initialize that one to max value as well. Okay. Now we have to scan over the collection of integers int n and numbers. Now, as we grab each value, we can finish that final part of input validation. I can say if n is less than or equal to 0, throw new argument exception. Only positive integers are allowed, or whatever you like. Okay, so the input's covered now. We checked the collection size and the each element, that it's positive. So next would be to find out if n qualifies as a new minimum value encountered, and most likely it will on this first iteration, right, when we have the two max values. So if n is less than min 1, or if it's less than min 2, it could be less than both, probably less than both the first time, right? Then we know one of those has to be updated. Now, in the case that it's not, that this condition is not met, we don't even have to handle that case, right? Because it means that n is a higher value or maybe equal. It could be equal to min 1 and min 2. But in either case, you don't have to update in that case, right? You already have minimum values. So we won't even worry about that. But inside here, we know something has to be updated. So the question is, which one? Well, we can check again. We can say, if min 1 is less than min 2, then we want to update min 2, right? We want to keep the lower value of the 2. We always want the two lowest values. If I updated the other way, min 1, then we would have kept a higher value than we needed, and that would throw off our calculation. So in this case, keep min 1 what it is. It's the lower. We want low. And let's update min 2 with n. And at this point, maybe min 2 did go below min 1. Doesn't really matter. And then, of course, we have to cover the other case where min 2 is less than min 1. And in that case, you want to keep min 2 and update min 1, right? Well, we always want the lowest. And so finally, when your for each loop is done, you can simply return min 1 plus min 2. You have the two values there. And if you are wondering, we know we can go to the docs, before we get yelled at for not bringing that stuff in. You can check the namespace that this class is in, and it's in system. So it should be the same. That should cover us for using the argument exception as well, but you can look that up if you want. Using system. Okay, hopefully we don't get yelled at. We'll run the test. Hopefully green. Good, looks green. We don't claim victory yet. We'll run the whole collection. And we're clear for submittal. I'll probably submit this way, even with the error checking in. Maybe someone will give us a best practice vote. But you might have gone about this another way. And so you could have used less lines of code, and maybe you'd use link. Let me see, do I have enumerable here? So we know enumerable, right? You could have done something like where you got the min from the collection, right? Use this min to kind of scan the input and get the first minimum value, and then maybe you remove that and then run min again on the remaining elements, and you get the second minimum value, and then you add those two up. But if you're not careful, like in the way I described, you'll notice that you're going over the collection of values multiple times. And so that's wasteful. Won't come up on Code Wars with small input sizes, but in real life with millions, it matters. So I tried to do it in a way here where I only had to scan over the input once, and then I could make that determination. But you'll realize, because they gave us this collection, just a simple array, right? You can't make any assumptions about the order of the elements, right? We don't know if this array is sorted. It's not guaranteed to be sorted. And if you call sort when you get it, right, you could have done that too. You could say array sort, and then just pull off the first two values, assuming that your sort order is ascending. If it was descending, you'd grab the last two values. And you could do it that way too. And then the quality of your algorithm would depend on how good the sorting algorithm was, right? And how the state of the input that you get in, if it was by default, if you got on average a good ordering that was good for whatever sorting algorithm you were using, right, it might work out well. Or you could get numbers in an order that made your sorting algorithm look bad. But the idea is that it's better to scan the collection only once if you can, and then get your result that way. And so that's what I did. I just maintained some state here, 2 local variables, update them, always have the lowest values at any time, and when you're done, you've got the minimum of the whole collection. Now, as you can imagine, there are data collections that have ordering associated with them. And so those are very powerful in that you can get to values quicker because you know certain things. You know that the data collection is ordered in a certain way. So you can imagine like maybe you've seen binary trees, with leaf nodes going down, and they keep the height to a minimum, and so you can sort of get to where you need to be relatively quick, very quick, even on a large input size. But we don't have that. There's nothing like that we can leverage here. There's no sort of magic, right? The two minimum numbers could be hiding at the end. We could have 1 million numbers come in, and the last 2 could be at the very end. We can't really cut short. We're sort of forced to process through all of the numbers because you never know if those last values are the minimum. So there's not really a way around scanning through the collection once, I guess is what I'm trying to say. But keep that in mind. If you do the extra work where you use a data collection that's ordered, you can do that. And it comes with a cost that you have to maintain the ordering of the data collection you're using, right? Because you might be adding and removing elements from it. And whenever you do that, it could mess with your ordering. So you pay a cost in sort of like a maintenance cost, right? You're always maintaining the order that you want. And in some use cases, that's well worth the maintenance cost, and you do it. And we'll learn more about that as we get into other data collections. But hopefully that was a helpful introduction. I'll go ahead and fire mine off like this. I don't think I have any comments in there, so do that, see what other people did. And you knew the link, the one-line link was coming, right? So cool, something to look by. Yeah, order by, take 2, the first 2, assuming it's probably doing ascending order. I think there's an order by descending as well if you wanted it to go the other way. And then just sum them. So yeah, perfect. Very readable, uses link. Good. That seems to be a popular answer. Someone else kind of rolling their own like we did. Like we said, yep, you can just sort them and then grab the first 2. So yeah, a few different ways to do that. See whatever works out for you. As usual, I like to hear about whatever answer you got, assuming it's different. Or if not, say, hey, I thought the same thing. That's good too. Hit me up with questions, comments, and I will see you in another video. Thanks.